Okay. So very good evening to everyone. So from yesterday we are discussing about that EDA processor, how we are just using with the help of data sets, that and all things. And today we are going to discuss about it, how we can make it with the help of data set, how we can make a model for the particular data set, how we can train the model, and what are that model it will be used for as to do the process of process in machine learning. So first of all, I have collected the data set which is related to that heart disease patients. So that the data set which is actually the data set collection which is available in that internet, we can able to do any kind of process. And specifically in machine learning, it will containing three types of machine learning will be there. So today we are going to discuss about with supervised machine learning. So the supervised machine learning, which is nothing but it will be executing with the help of past experiences and the label data. So label data, which is nothing but if we have trained the model with the help of apple, means we need to given the apple shapes and how that it will, what are the attributes it will have, and also we need to pass the name with that apple. So we must need to transfer the machine via when we have applied to that supervised machine learning, means we have to do the process of knowledge and knowledge response also we have to given to that machine. From itself the machine has been identified, machine has been learned, and it has been predicted. So here we are going to do the process of heart disease predictions. And in specific especially here in this particular data set we have collected based on the supervised machine learning process only. So in here we are going to make our target value as this one, this is our target value, and we are going to do the process with the help of these data set, these trained data, and this data set. In this data set it containing data as well as labeled. So here the label, which is nothing but target only. So first let me show you, yesterday I show you, once again I will repeat you. So here we are going to use the process of Anaconda Navigator, which is nothing but one of the editor which we have implemented the Python or any machine learning programs. And in this Anaconda Navigator we are going to use this Jupyter Notebook Launch. So when you have call the Jupyter Launch, it will be appear in your browser like that. And here I already told about you, here we are down making a folder in any directories. So I made a folder in desktop, and in this desktop I have copied and pasted that my data set hot.csv format. Okay, now let me make one new Python file. So in this Python file, the simple process how we can do the what are the techniques we are going to implement it here. So first we need to collect the data sets that already we have collected it, the data collection. The next thing is then we need to apply the data pre-processing steps and the EDA process, and we need to apply the model evaluation and model fitting. So these are the process we are going to implement with the help of this hot.csv file. And first we have to importing the required packages. So here the required packages basically we have done with an yesterday process same only. So this is the how we can, I am going to import the same like only imports numpy as np and imports pandas okay. These are the basics packages which is request for anything. So here the same process I am going to apply it. First I have to read my data set. So how can I read my data set? With the help of pandas packages only. So we need to call the pandas pd dot read underscore csv. The same process we have to apply it here only. Just a minute. data set is my variable name is equal to pd dot read underscore csv, and my data set name is hot dot csv, and now I am printing the data set values. It will be appear on like this. So this is my data set value. Okay, so let me show it the next part. So here the next process what we are going to do, so we need to apply the data pre-processing steps. So data pre-processing, which is nothing but we need to ensure whether the data it has been it have a structured format, it has any null values or any unnecessary things it will have, like that we are going to check it in that process of with the help of data pre-processing. So data sets, my variable name data sets dot is null of. So before that we need to identify our data set futures name, futures type, what are the types are there. So here every object except the old peak, everything which contained into that integer object. So we can easily apply the any mathematical formulas like mathematical functionalities only we can able to apply it here. So here we are applied with the help of decision trees and the Naive Bayes algorithm. Also we can able to apply support vector machine, random forest algorithm, these kind of things we can, because we are going to predict whether the patients are heart affected or not, like that we are going to predict with the help of machine learning. So next process I am going to do the EDA process, because machine learning it will be containing that 5 process. First thing is then data pre-processing, data collection, and data collection which is nothing but you can able to collect the data from anywhere like Kaggle and Google data sets and UCI world, like that many data sets sites are there. It is an available only, and you can able to download any kind of data sets from these kind of websites. The next thing is then data pre-processing. So data pre-processing, it is in that particular module also the EDA will be included. So in this particular model, we are most of the time we can able to identify, we can able to get more amount of information. Also we are going to structurize our data sets, because while collecting time it will containing many of unnecessary things like NaN values, like that it will be having many data sets, empty cells also it will be containing. So the next thing is then we have to fit the model evaluation and the model fitting, and finally hyper tuning parameter. So these are the procedures how we are going to apply the how we are going to make the machine learning projects. Okay, so the next thing is then now I am going to check whether the data set it will containing any empty columns, like that I am going to check. So how I can apply the data pre-processing? So data set, first I have to call the describe of function. Describe of function, why I have to use? So it just executing whether it is having how many counts, and we can able to easily analysis how much of the values of data's unique values will be there. So every information we can able to get it with the help of describe of function. So which is nothing but descriptive statics or descriptive analytic functionalities. And the next thing is then we are going to implement data sets dot is null of dot sum of. So here you can see everything should be in 0 only. There is a no values which is there is a no value no null values in our data set correct. So it will be having a correct format only. So next we are going to apply the EDA process. EDA process, which is nothing but yesterday we discussed about it only. It just extracting more amount of information from our data sets. So we can easily able to create, we can easily able to make the visualization in variety of graphical format like bar chart, line chart, and pie chart, like that will be there. So the same process I am going to apply this for this purpose, for this here also. So data sets, wait a minute. So now if I am going to count, I already told about, so we are going to target our variable in this target one, I mean in our data set is target only our futures. This is our target value. This is nothing but target class. Okay, we are going to do the process, we are going to take a independent variable which is nothing but target only. So I am going to take how many of 1 values will be there, how many of zeros value will be there. I am going to check it out. First, import zbond as SNS and SNS dot count plot x is equal to target so you can see this. So from here itself we can easily analyze above the 80% or 60% amount of data, the number of ones will be there. So from itself only we can able to do the process. So we are going to implement the process of next process is that similar like we can able to apply the EDA process in many features like here itself you can see, you can exchange old peak also, you can have slope variable and tall CA. So many of the values will be there, you can able to apply it here. So the next process I am going to apply that text and train split. For that purpose you have to first you have to assign the independent and dependent variable. So first of all we have to assign the labeled. For that how we can make, so labeled I already told, we are going to target with the variable name is target, we are going to make a class as in target only. So x is equal to data sets and data sets drop or else ilog dataset dot drop off or else directly we can call now the next you can see x and y value here, x dot head of function, except the target all the values has been printed here, and I have to take my y value same like. So y dot head of, So what is the meaning of this tool? This two line, actually here I am just making an target classes. So my target class is target variable only. Okay, the next thing I have to split it into. So I need to mention, I have to pass the target independent variable and the dependent variable to my machine. Here we are going to split our data set into two parts. First part is an training part and the testing part. For that purpose, how we are splitting means, with the help of train and split functions, module will be there. With the help of that module only we can able to split our data set. And while splitting time, we have to pass the two variation. One is independent variable, another one is dependent variable, which is nothing but when we target variable and the class labeled variable. Okay, so same like here you can see, I just taken the 4 value: x train, y x test, comma y train, comma y test is equal to, so sorry, before that you have to import your file. So from scikit-learn dot model selection import train and split functions. So what is the meaning of this line? So you are going to call the train and split module. We need to accessing that package module. So from scikit-learn, it's a package which is nothing but scipy and numpy. It's a combination of scipy and numpy, and which we can able to solve many of the complex program in Python with the help of these scikit-learn sklearn packages. In that, sklearn is the main module. In that submodule of model selection, we are accessing this import train and test split function. Okay, so here now I am making that 4 variable: x train, comma x test, comma y train, y test. First, you have to pass your dependent and independent variable, and you have to mention the test size. So here I am mentioning my test size is equal to 0.2, which is nothing but 20% amount of data I am going to assigning for the testing purpose. The remaining 80% amount of data I am going to apply it for the training perspective. So the training purpose is nothing but we are going to train the machine with the help of with the help of values which we are passed into the x train and y train. And after train the machine, while we have passed the test data, how the machine has been performed well, we can able to analyze the performance matrices. So performance matrices, which is nothing but how our machine has been performed very well or not, like that we can able to identify it. So now you have to call that train and split functions. Okay, now you can check x train value, also you can check the y train value. So these are the values. If you want to plotting for the x train and y train, you have to plot that values as SNS dot bar charts. So you can easily plotting the values, which is nothing but which is we can able to solve like the data how it will be performed. the data we can, so zeros and so on, how many values are there, like that we can able to easily analytics here. So the next process is how we are going to use this trained data and test data to the model. So here our model, which is nothing but we are implementing the first model, which is nothing but Navy Bayes algorithm. So Navy Bayes, which is Navy Bayes is one of the classifications algorithm which has been used for that value with the help of probability and frequency based it has been. So in the behind the thing, it will be having some mathematical calculations while entering into the first part of Navy Bayes algorithm. First it will be finding that frequencies for each and every futures, and then it will be getting more amount of probability for each and every futures. So while I'm getting into that Navy Bayes algorithm, I have to pass the data I have to pass the test data which is more relevant to that how the machine has been getting overrated or like that we can able to do. So let me show it. How can we import the Navy Bayes mean from scikit-learn dot Navy Bayes imports multinomial. Now I am just making this multinomial as a constructor with one variable name. So now np is equal to Navy Bayes or else multinomial of the constructor. Next step, I am going to train my model with the help of multinomial Navy Bayes algorithm. So how can I call that here? So first fit of keyword. So np dot fit of, we need to train that, we need to pass our two values, the xtrain and ytrain data. So we are getting in our values like this. This is a model selection. Now our machine has been trained. You can able to check, you can able to store that in any variable, like for example, so if you are printing np.1, you can able to get the value multinomial. So which is actually this multinomial NBA, how our data in behind the thing in background, how the data has been trained means it's also one kind of plotting only, because Navy Bayes will collect, I already earlier said about this. So first it will be collecting all this data as in format of frequencies based first. For example, xtrain, what it will be having age and gender. So how much of ages values will be there, how much of gender value will be there. First it taking each and every futures for the frequencies, then it checks the probabilities for each and every. So everyone should having an values for that every probability and frequencies will having a values. Okay, then we are going to pass the test data. So here our test data, which is nothing but this only. So I am going to pass the test data, this data. So while I have to pass this amount of data, if I am getting an output zeros or ones like that, means if it is, I mean if the machine has been getting a value 1 means they are not affected with heart disease. If the machine has been given value 0 means they are affected with that heart disease. Like that only we can predict it. Our machine has been predicted. So model 1 is equal to np dots predict, the keyword which is passed to that x test, I passed it here. Now I am print the value here, model 1. You can check, these are the amount of data we have passed, 20% amount of we are already passed. So we are getting an amount, we are getting an actual output is 1 and 0 0, like that we are getting an prediction out. This is our predicted output. So how we are getting that means we help, I mean our machine has been trained. Our machine, how it will be trained, we have passed the xtrain and ytrain test data here. So this test data it will be containing both attributes and that if these kind of attributes will have means they have a disease, like they have disease or they have not disease, like that we are giving a knowledges as well as. So from that kind of situation the machine has been learned, and while I have to pass the predicted, the test data means we are getting an output like zeros and ones. So 0, if the output will came 0 means they are affected with that heart disease prediction. If it is 1 means they are not affected. That's the meaning of this zeros and ones, which is one we are getting whenever we are applying this supervised machine learning. We are getting in binary outputs only, either zeros or ones or yes or no, like that we are getting in values. So next thing is then how we can check our machine has been performed, how we can check the performance of machines. So with the help of accuracy scores or else confusions matrix. So these are the performance matrices which is most widely used in that supervised machine learning performance checking. So here from scikit-learn dot matrices imports accuracy score and confusion matrix. Both the packages I have imported it here. Then I am going to check first accuracy score of. Here we need to pass our actual our predicted output and our actual output. We have to pass predicted value, actual value. We have to pass the two variability here. So our predicted variable is model 1 and comma our actual value is y test. So here I have passed it and I am going to check the value. So 77% of 77% our machine has been correctly performed. 77 is an average performance only, it's not an bad. So when we are getting more amount of training data and we can able to get more, we can able to increase our accuracy scores. Okay, and the next thing is how we can getting it performing of confusion matrix. So how confusion matrix, which is nothing but I will show you. CNF is equal to confusion matrix of the same our model value and the actual value. We have to pass it here. So first value, which is called as a true positive and true negative positive and true false positive and false negative. This is that way which the matrix has been explained it here. So true positive, which is nothing but our machine has been correctly predicted about the 13 value, so that we are getting an accuracy score 77%. So this is one of the important model in that supervised machine learning, either classification or prediction in supervised machine learning. So naive Bayes, and after that we are going to check the second model, which is nothing but decision tree. So when the decision tree means in the name of, we can able to easily explain the machine how it will be plotting in the backend. So first, based on the tree based, it will be plot. Based on that, we are getting an output like for that decision tree. It is also giving an output zeros or 1, like that only it will be getted. So let me show you. Same like from scikit-learn dot tree classifiers imports decision tree classifier. Same like we have to take that constructor here. So decision tree is equal to decision tree classifier of, then I have to pass my value dt dot fit of x train. The whatever we pass, the same procedure here, x train and y train, and finally I have to pass the model 2, which is equal to dt dot predict my x test. So then model 2, zeros and 1, the value which we are getted. So the same procedure only. So here I have to call first decision tree header file. I have imported the header file for decision tree. Then I have to make one constructor for, I have stored all this value of, I have to accessing all the decision tree properties with the help of this dt. So I have make one class in the district constructor format. I have stored it with the help of dt. I can able to call the fit of keyword and the predict of keyword. Whenever we have passed the fit keyword, where that machine has been trained with the help of fit keyword, and while fitting keyword, it will having two parameter. One is x train, another one is y train. X train and y train, it is already you know that it will containing knowledge and knowledge responses both will. So the next, we after trained the machine, we are pass our test data. So we are passing the test data, we will get an output like this. And this is also we are going to check that how the machine has been performed. So the navy bias, dt is equal, or else accuracy 2 is equal to comma y test and accuracy 2. So 72%. It's comparing very low when that navy bias algorithm. So navy bias which is given 77, decision tree which is given a 72%. So here also we can able to give that we can able to give the performance estimations. Then also you can print that confusion matrices as well as like so 50% it should be in correct value, and the 13 and 14, 29 which are remaining values, which is our process. We are getting in the accuracy scores or and confirm confusion matrices in the while we have explained with that data set. So these are the in this way we are exploring more amount. We are exploring more amount of, we can able to more amount of data, and also we can able to predict the values itself here. So also in this specific of data, while entering into any data science process or machine learning process, we have some kind of structured which is data preprocessing. As earlier we can discuss it about it. The same procedure only we have followed it, and so here I have taken very less amount of data set for the training perspectives. When we have passing amount, a large amount of data set like 50,000 or 10,000 amount of data, if we have to pass. While training time it will be getting more amount of person, because how much of data we have given to the training person, from itself our machine has been trained very well, and we can easily able to get more accuracy of scores, and we can able to get the accuracy score. Sometimes our model has been getting an overfitting errors, which is nothing but sometimes it will be getting 100% of accuracy score, which is nothing but accuracy scores which is overfitting model only. Like that we can able to analytics that. How we can avoid it? That means in that kind of scenarios we need to make the validations, cross validations will be there, and also we can able to make some dummy values. With the help of dummies we can avoid these problems. And here I'm just comparing, if I need to comparing those performances of algorithms, I can able to comparing the both algorithms with the help of bar charts, and we can able to not only bar chart, many of the charts for that comparisons will be there. So right now I am going to implement the bar chart for that comparisons graph here. Okay, let me show you. So import matplotlib dot pyplots as plt, and objects. This is equal to First one is a decision tree. Let me show you. Maybe basis. The next thing is another one variable I have created for 1 minute. Object is equal to np dot arrange length of my objects, and I have to pass the y position, which is nothing but I need to mention the values. Okay, so more accuracy is 1, accuracy is score. ACC. And finally I have to create the plots. So plt.bar, we need to must pass the two values. Here my values are y position and comma objects, and plt dot my xticks, I have to given any values like names, name only. So I have to given any I just given algorithm. And next plt dot show off. Wait a minute, let me arrange it to you. I'll show it separately, separate format, how the plots has been assigned. Okay, so the performance is here, the zeros and ones, how the zeros and ones we are get it like that, we have to get it here. And you can able to give x labels, and how we can pass the x labels, decision trees, and you have to mention any names which is present on that particular values. So I have to given right now null for your understanding. You can see that value here. So you can able to give that x null and x label and the y label, and you have to giving more number of values for getting an accuracy scores like that. It's just an performance comparisons between the two modules. Based on this visualization, we can analyze which should be performed very well. So in our cases, the Navy based algorithm should be performed very well. We have seen it here. the same like whatever you have get it, that will be an that will be represented, that will be generated in that our graph. Okay, so I hope so you can understand it, this concept of performance evaluations and this accuracies matrix, how we are getting a model, how we can able to models that and all things. So hopefully you will be getting in some ideas about how the machine learning project has been worked and how we can able to make that product like that. You will be getting in some ideas. So if you have any doubts, you are just post the comment doubts in that comment sessions. So I hope so everyone have been getting a little bit of amounts like amount of the knowledges which has been based on our sessions. Okay, so hopefully, do you have any doubts? You just post your comments in that comment box. Okay. So I have pinned you the attendance link. You can check it out. You can able to upload it here. So finally, so thank you for organizing this wonderful event, Hemalata ma'am and that Panimalar Institute, Panimalar group of college engineering, or from this event we can able to make and I make that very clearly, and we can give some amount of knowledge to that to the students, and we are happy with sharing our knowledge to that this kind for organizing this event. We very thankful. So thank you Hemalata ma'am from Panimalar Engineering College. Thank you. You can post your attendance in that link which I have pinned it here.